You'll be pleased to know that we have yet another remote control deadbolt video for your perusal. This version of it is adapting the remote so that it works with two Zigbee modules. These are available on Amazon. These are actually relay driven, way overkill for this purpose, but they work fine for their application. So there are two of them because you need one for each switch because these are single channel ones. I believe there are ones that have more, but these are single channel, so there's two of them. And I've put them in this little kind of test bed enclosure so they don't move around and short things out. Now, from a wiring standpoint, it's straightforward. Both boards need power. So there are leads that go from this board, wrap around here, and go here, and then those get paired up and then they go out to the external power supply. So I've got this side hooked up to power supply. So that gives the boards power. And as I talked about earlier, I tied into one of the Zigbee chips to get the 3 volts that the remote control needs, because the remote needs 3 volts, 3.3 volts. It doesn't want anything higher. Now, there are alternatives to this. You could, instead of doing that, and I realize this is fiddly soldering here, so you might want to avoid it. But instead, what you could do is you could add in, and I'd probably tie it into here, you could add in like a buck converter. Then there's buck and there's boost. Boost is the obvious one. Boost takes a lower voltage and raises it. Buck takes a higher voltage and brings it down. Now this is a pretty hefty one that would probably not be useful for this thing, but they do come in pretty small sizes, and these are dirt cheap on Amazon. You get like a dozen for, I don't know, under $10, I'm sure. So you can wire these up, and they have a super teeny tiny variable, whoops, let me move it up here, super teeny tiny variable resistor there where you set the voltage. So that, be careful with these when you are using these. Make sure that you test it on your bench with your multimeter and a bench supply before you actually hook it into your circuits, because you never know what these are set to. They could be set really high and blow everything up, and then you'll have a really bad day. So watch out for that. So here in this one, this is the trim pot in this one. And then on this one, this blue thing with the brass dial, that's the trim pot on that. So I hook these up to the bench. A lot of the times what I'll do is I'll go through, if I get a bunch of them, I'll go through them, set them all real low so I don't have an oopsie later on. And 3 volts is usually safe for real low. So let's see, things I found out about this wiring. One, they don't mark a positive or negative for the input. Now, their little tiny instruction guide says positive on one side, negative on another. But this, to me, this chip right down here, and the equivalent is right up over here, that is a bridge rectifier. So that would take AC and turn it into DC, or in this case, it will take either polarity and correct the polarity. I think that's what it's doing. I think that's what they're doing there, is they're using it to, you could actually miswire this and you'd be okay. Now, I wouldn't want to like misgang these together. That would probably be a bad thing. So anyhow, I've got this wired in, and I made a little 3D printed sled, because this is more of a demonstration unit so that other folks can convert it. So I just made a little sled instead of anything. But what it could be is, it could just be, if I was going to put a cover on it, I'll probably put a cover on it. You could tuck it in like that, and it's actually below the height of the relays. So by lucky happenstance, it fits. A couple of other things I want to point out. I have no idea how these boards work, so I can't really test them, but I'll leave that to the users. This little black coil you see on these, that's a 433 megahertz antenna. So I believe these boards have multiple transmitters on them, so you could use either 433 or whatever Zigbee uses. I don't remember. Now, talking about 433, most of these remote controls are 433 megahertz, and in order to have the proper length of antenna for that, a full wave antenna would be, I want to say about 70 centimeters or inches. I don't know. I can't remember. I looked it up earlier. But obviously you need a long wire. 27 inches. That's what it was. 27 inches. That's not going to work. So what I did is with radio transmitters, you could use divisors of the full wave. So you'll hear terms like full wave, half wave, quarter wave. And in this case, quarter wave for 433 megahertz is about, I think, a little shy or around 7 inches long. So I took off their little chunky wire and I put just a piece of wire here that is cut to the correct length. And while that's not going to really make or break anything, the ideal length, if you want to stick as close to the ideal length in a quarter or half or full wave or even an eighth to the transmitter, because that way the transmitter's power, all of that power is getting transmitted out versus losing some of it because you aren't using the right correctly tuned antenna. Antennas are a whole art on themselves. Now if you remember, they did have the little black wire soldered to this metal ring around here, so there was an attempt to get up to quarter wave, but this is still about 2 centimeters too short to be the true quarter wave antenna length. So better than the little 1-inch thing, not as great as the correct one. So I figured I'd put a correct one on here anyway. So that's this thing. So what would happen now is this will get buttoned up. Oh, that's right. The buttons are hooked to the relays, so to the normally open or otherwise aka not connected contacts, so that when the Zigbee turns the relay on and switches it, it will then trigger this. And I can manually see if I have power. Oh, I don't have power because I haven't turned it on. Let me turn it on. So I got my bench supply there. And right now the bench supply, I set it to low end 7 volts, and I said no more than 100 milliamps, and it's only taking about 50 milliamps right now. It'll probably be higher when it's transmitting, but now I could test the remote and look, little blue LED lights up. So I know that this is getting power, enough power, and it's transmitting. I know that these two boards are getting some sort of power because they're lighting up. So that's a good sign. When I powered this up just now, it's always a good idea, again, start low, work your way up. If you get an inexpensive bench power supply that allows you to go up to about 25 volts DC and allegedly a couple of amps, they really aren't. But what's nice about them is that you could set the maximum amperage or the wattage to supply, so you could start it out real low so you can give it a good smoke test without hopefully without blowing things up. So that's it for this. I think I've had enough working with remote controls and Zigbee relays for the moment. I'll probably print out a cover for this and call it a day. Thanks for watching.